తెలంగాణ ప్రభుత్వం విడుదల చేసిన 2022 టెట్ ఫలితాలలో రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్ ప్రభంజనం. టెట్ పేపర్ 1లో 133 మార్కులతో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన జె అంజని. టెట్ పేపర్ 2 మ్యాథ్స్ సైన్స్ విభాగంలో 129 మార్కులు, 127 మార్కులతో స్టేట్ టాప్ ర్యాంకులు సాధించిన జె అంజని ఎన్ సరిత. టెట్ పేపర్ 2 సోషల్ స్టడీస్ విభాగంలో 122 మార్కులతో స్టేట్ టాప్ ర్యాంక్ సాధించిన ఏ మమత. మరియు అన్ని పేపర్లలో 90% ఉత్తీర్ణత సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. 2017-18 డిఎస్సి ఎస్జిటిలో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన మహేష్. స్టేట్ టాప్ 10 ర్యాంకులతో పాటు అత్యధిక ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. మరియు గురుకుల టీచర్స్లో టీజీటీ మ్యాథ్స్ స్టేట్ ఫస్ట్ ర్యాంక్ స్రవంతి, టీజీటీ బయో సైన్స్ స్టేట్ ఫస్ట్ ర్యాంక్ సుధా, టీజీటీ సోషల్ స్టేట్ ఫస్ట్ ర్యాంక్ బి శ్రీధర్, టీజీటీ సోషల్ స్టేట్ సెకండ్ ర్యాంక్ రాజేందర్ రెడ్డి, టీజీటీ తెలుగు స్టేట్ ఫస్ట్ ర్యాంక్ అంజన్ కుమార్, ఫిజికల్ డైరెక్టర్ స్టేట్ ఫస్ట్ ర్యాంక్ రాజ్యలక్ష్మి, ఫిజికల్ డైరెక్టర్ స్టేట్ సెకండ్ ర్యాంక్ దివ్య, టీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ శ్రీలక్ష్మి, పీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ మురళి, పీజీటీ ఇంగ్లీష్ స్టేట్ థర్డ్ ర్యాంక్ యాదగిరి. 2017-18 డిఎస్సి గురుకుల టీచర్స్లలో 70 నుండి 80% ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. టెట్ మరియు డిఎస్సి కోచింగ్ కొరకు డైరెక్టర్ సిరికొండ లక్ష్మీనారాయణ గారి సారథ్యంలో అత్యుత్తమమైన అధ్యాపక బృందంచే కొత్త బ్యాచ్లు ప్రారంభమైనవి. వివరాలకు సంప్రదించండి 9246208422, 8855555202, 88585900, 8008954440, 8008954448, 8520844463.
Hi, hello. This is your SRINIVAS Mathematics faculty, Ramaya Coaching Center. So in this video, we are going to discuss about number system. Number system, which is a part of TET paper 1 and paper 2, both APTS and C-TET. So let's discuss about number system. In this number system, we are going to discuss about types of numbers, LCM, HCF, fractions and decimals, surds, squares and square roots, cubes and cube roots, etc. So let us see first types of numbers. Types of numbers, in that first one, set of natural numbers. Set of natural numbers is denoted by capital N. They are capital N is equals to 1, 2, 3, 4, 5 and so on. Observe that these are only called counting numbers. And also observe, in the set of natural numbers, the first number is 1. That is only the smallest natural number, and we don't know what is the last number in this set. So the smallest natural number is 1 and the largest natural number can't be determined. So we can't see largest natural number in this set. And also in between any two natural numbers, between 4 and 6, there are how many natural numbers? 1. Between 2 and 10, how many natural numbers are there? 3, 4, 5, 6, 7 and 8. So between 2 and 10, there are 3, 4, 5, 6, 7, 8. Only 6 natural numbers. So between 2 and 10, there are 7 natural numbers. They are 3, 4, 5, 6, 7, 8, 9. So when we are using the word between 2 and 10, we no need to count extreme numbers. Just we have to count the numbers which lie between them only. So they are 7 natural numbers. Between 1 and 20, there are 18 natural numbers. So final conclusion is, in between any two natural numbers, there are finite number of natural numbers. In between any two natural numbers, and how many natural numbers can be seen between any two consecutive? Consecutive means serial numbers. So between 2 and 3, there is no another natural number. Between 4 and 5 also, we can't see any natural number. So even between 8 and 9, there are 0 natural numbers. But as we said earlier, in between any two natural numbers, there are finite number of natural numbers. Between 8 and 9 also there are finite number of natural numbers. They are 0 natural numbers. See, this is about natural number set. Now, another set is set of whole numbers. Set of whole numbers is denoted by W. Set of whole numbers nothing but set of natural numbers along with 0. All the natural numbers along with 0 is called set of whole numbers. And we can see same properties here also. What is the smallest whole number here? Smallest whole number is 0. Largest whole number cannot be determined. Also, there are finite number of whole numbers exist in between any two whole numbers. So, same properties as natural numbers, only the thing is 0 is extra here. Set of integers denoted by Z or I. Integers are nothing but negative of natural numbers along with whole numbers, or negative of natural numbers 0. We can see from so on -3, -2, -1, 0, 1, 2, 3, etc. Observe that smallest natural number exists, that is 1. Smallest whole number exists, that is 0. Largest natural number, largest whole number does not exist. But here, observe the set of integers. What is the smallest integer? Does not exist. What is the largest integer? Does not exist. There are 3 types of numbers involved in this: negatives, positives, and 0. Here also, between any two integers, there are finite number of integers. Between any two consecutive integers, there is no other integer. Another type of set, that is set of rational numbers denoted by Q. A rational number which can be expressed in the form of P by Q. Which can be expressed in the form of P by Q, where P is numerator, Q is denominator, along with the conditions Q not equals to 0 and P comma Q both are integers. P by Q form, denominator is non-zero and both numerator and denominator are integers. So that we can define set of rational numbers as like this: P by Q such that Q not equals to 0, P comma Q belongs to Z. Any number is of the form P by Q. Along with these two conditions is called a rational number. For example, 2, 3 both are integers. By writing in the form of 2 by 3, it can be a rational number. Observe that whether it is satisfying these conditions or not. Let us check first condition. It takes the form P by Q, and second condition is denominator 3 is not equals to 0 anyhow, and p comma q both are integers, not only 2 comma 3, you select any two integers. For example, minus 7, 3. By writing as minus 7 by 3, it is in the form of p by q. Along with q not equals to 0, p comma q both are belongs to z. It is also a rational number. Suppose if I take 0 comma 9 by writing 0 by 9, it is also a rational number. But if I take 5 comma 0 and by writing 5 by 0, observe that even though it is looking like a p by q form, but it is not a rational number. So rational number means not only in the form of p by q, it should also satisfy the remaining two conditions. Those are q not equals to 0 and p comma q both are integers. It is p by q form, okay, first condition satisfied, but second condition not satisfied. Second condition is q should be non-zero, denominator should be non-zero, but here 5 by 0 is there, denominator 0 is involved, it is not a rational number. Observe here, rational number is of the form p by q, but any number in the form of p by q may not be a rational number. For example, 3 by 11, it is a number in the form of p by q, it is also a rational number. For example, 2 by 0, it is also in the form of p by q, but it is not a rational number. So final conclusion is every rational number in the form of p by q, but any number in the form of p by q may or may not be a rational number. And also, as we have seen properties in the above three sets, natural number set, whole number set and integer set, here you see 1 by 3, one rational number, 2 by 3, another rational number. These are two rational numbers. 3 is also a rational number because it can also be expressed as p by q form. Simply 3 by 1 or 6 by 2 or 9 by 3, etc. So 3 can be expressed as p by q form in many ways. So that's why 3 is also a rational number. Not only 3, 2020 also a rational number, can be expressed as p by q form along with remaining two conditions. So that's why 2020 is also a rational number. Not only 3 and 2020, every natural number 1, 2, 3, 4, 5 so on, every natural number is a rational number because every natural number can be converted into the form of p by q just by writing denominator is 1. So that's why every natural number is a rational number and every whole number. So already we have seen the difference between natural number and whole number is just one element, that is 0. You see, 0 can also be expressed as 0 by 5. Not only 0 by 5, 0 by anything we can write, which takes the form of p by q. So that's why 0 is also a rational number. Already we have checked just now. From 1 onwards they are called natural numbers only. So every natural number is a rational number. Already we have discussed. Now we can conclude that every whole number is also a rational number and every integer is also a rational number because every integer can also be written as p by q form easily. For example, minus 8 is an integer. Let us check whether it is a rational number or not. To say that minus 8 is a rational number, we have to convert it into the form of p by q along with remaining two conditions, q not equals to 0, p comma q both are integers. See, just by writing minus 16 by 2 or simply write it as minus 8 by 1. So it is p by q form. First condition of rational number is okay. Denominator q is not equals to 0 even in this form or in this form. Denominator is q is not equals to 0, okay, and observe that both numerator and denominator are integers. Minus 16 is an integer, 2 is also an integer. So that's why minus 8 is satisfying each and every condition of rational numbers. That's why minus 8 is also a rational number. So every integer is a rational number. Decimals 0.5, it is not a natural number, it is not a whole number, it is not an integer. In the above three sets, natural number set, whole number set and integer set, it is another number named as decimal. Let us check whether it is a rational number or not. So 0.5 can be written as 5 by, in the denominator, after the decimal point, how many digits are there here? Only one digit. That's why in the denominator after 1, write only 1 0. Now let us check whether it is a rational number or not. See here, it looks like P by Q form. P by Q form, okay. And denominator Q not equals to 0, okay. And both numerator and denominator, 5 is an integer, 10 is also an integer. P comma Q belongs to Z. Belongs to Z means P comma Q both are integers. Here 5 comma 10 are also integers. That's why decimal is also a rational number. 0.5 is a rational number. What about 0.532? Let us check whether it is a rational number or not. If it can be expressed into the form of P by Q, there is no doubt to say that it is a rational number. Now you see, removing this decimal point, just you write remaining digits 532 by, after 1, how many digits are there here? 3 digits, write 3 zeros. Now you see, it takes the form of P by Q. P by Q form, okay. Denominator Q not equals to 0 is also okay. And P comma Q, 532 and 1000 both are integers. So that's why it is also a rational number. So 0.5 is a rational number. 0.532 is also a rational number. Let's see some more decimals. 1.678 can also be expressed as, removing decimal point, write a number together all these digits, that is 1678 by denominator after 1, that is not this one, even it is 5 also, we have to start with 1 only. After the decimal point, how many digits are there you count? 1, 2, 3, only 3 digits are there, keep only 3 zeros. Observe that it is also taking P by Q form. Q not equals to 0. P comma Q both are integers. 1678, 1000 both are integers. That's why it is also a rational number. Not only this, if you write any terminating decimal, that is definitely can be converted into the form of P by Q just by removing decimal point and writing a number together in numerator, and in the denominator after the decimal point, number of zeros as the number of digits. So it takes automatically P by Q form. So it becomes a rational number. That's why we can conclude that every natural number is a rational. Every whole number is a rational. Every integer, we have seen some decimals also, but we have checked only one type of decimals. Observe all those decimals: 0.5, 0.532, 1.678, etc. decimals. Observe these, all of these are stopped at a certain digit. So that's why these are called terminating decimals. These are called terminating decimals. So we can conclude a statement that every terminating decimal is also a rational number. Every terminating decimal is also a rational. So by writing this statement, we are getting a doubt that there is one more type of decimal, that is non-terminating. So what about non-terminating decimal? Let us check whether it is a rational number or not. Non-terminating decimal means a decimal which never stops, which never ends. So this is called non-terminating decimal. Observe that. First one is terminating decimal. Second one is never ending. It is a non-terminating decimal. Third one is also a non-terminating decimal. These two are non-terminating decimals. So non-terminating means they are never ending. Observe that 0.537601278 so on is equals to. So we have seen already, to convert decimal into P by Q form, we have to remove the decimal point, and in the numerator we have to write a number together all the digits before the decimal point, after the decimal point. Okay. However, before the decimal point there is 0 only. 537601278 so on by, and what we are writing in the denominator? In the denominator we are writing a number after 1, number of zeros as the number of digits after the decimal point in the given decimal. How many digits are there? You count. 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. After 1, how many zeros I have to write? No evidence. Cannot be determined. So that it is, even though in P by Q form, it is not satisfying remaining two conditions like third condition. P by Q form okay, looking like P by Q only, having numerator, denominator, whichever the number, but Q not equals to 0 also okay. Anyhow, after 1 some zeros means it never be equal to 0, but fails to satisfy our third condition, that is both P comma Q are integers. Here we don't know this is an integer, we don't know this is an integer or not. Where it ends we don't know. Not a rational number. Another type of decimal 0.33333 so on. It can also be written as 0.3 bar. Only one digit is repeating, that is 3. So we can write it as 0.3 bar. It is called non-terminating decimal, but only one digit is repeating. So that's why it is called non-terminating repeating decimal. Only one digit is repeating. Suppose 0.23232323 so on. It is also non-terminating decimal, but it is also repeating decimal. Here 23232323, two digits are always repeating. So that's why we are writing 23 bar. Bar for two digits. How many digits are repeating? We have to write upon them a bar. 0.153, 53, 53 and so on. It is also non-terminating but repeating decimal. It can also be written as, what are the digits repeating here? 53, 53, 53, 53 and so on. That's why bar for only these two digits, 5 and 3. So it is non-terminating but repeating decimal. Already we have seen every terminating decimal is a rational number. Now non-terminating, non-repeating decimal, it is also non-terminating. The difference between them is non-terminating, non-repeating decimal is not a rational number. And let us see whether non-terminating repeating decimal is a rational or not. So before going to discuss that, we need to define periodicity and period. See, 3.123, 123, 123 and so on. This can be written as 3.123 bar. Here, how many digits are repeating? Once you observe, only 3 digits are repeating. 123, 123, 123 is repeating every time. That's why bar is used for only those 3 digits. Here 1, 2, 3, 3 digits are repeating. Number 3 is called periodicity, not this number 3, not this number 3. The number of digits repeating, 3 digits are repeating, that is called periodicity. And what is the number repeating every time? 123, that is called period. So periodicity means it is the number of digits repeating in the given decimal. Period means what is the number repeated in the given decimal. See, one more example. 53.756 and so on. It is also non-terminating but repeating decimal. So what is the number repeated here? 56. Can also be written as 53.756 bar. 53.756 bar. Observe that how many digits are repeating here? Only 2 digits, 5, 6. So that its periodicity is 2. What is the number that it is repeating every time? 56 is the period, 2 is its periodicity. So this is the periodicity and period in the given decimal. Now let us check. Non-terminating but repeating decimal is a rational number or not? 0.33333 so on, which can also be written as 0.3 bar. When we can say that 0.3 bar is a rational number, if it can be converted into the form of P by Q along with remaining 2 conditions. So let's try to convert it into the form of P by Q form. Let x is equals to 0.3 bar. What about its periodicity? Periodicity is 1 because only 1 digit is repeating. What is its period? Period is 3. See, whenever periodicity is 1, multiply the equation 1 both sides by 10. Left hand side 10x, right hand side 10 into 0.33333 so on, which can also be written as 10x is equals to 3.3 bar. So 1 decimal point is moving left while multiplying with 10. Now you see equation 2 minus equation 1. 10x minus x is equals to 3.3 bar minus 0.3 bar. 10x minus x, 9x. 3.3 bar minus 0.3 bar is 3. X is equals to 3 by 9. So we can cancel in 3 table. 3 ones, 3 threes. So what is our x? 0.3 bar is equals to 1 by 3. 0.3 bar is nothing but non-terminating repeating decimal. With the help of its periodicity, we can convert it into the form of P by Q. Not only P by Q form, it is Q not equals to 0. P comma Q both are integers. That's why it is a rational number. Decimals basically 2 types. In that, first type is terminating decimal. Second type is non-terminating decimal. We have seen already every terminating decimal is a rational. Every terminating decimal is a rational number. Non-terminating decimals, again 2 types. Non-terminating, repeating, non-terminating, non-repeating. Non-terminating, repeating decimals, just now we have seen by taking one example like 0.3 bar. All these are rationals. Non-terminating, non-repeating decimals cannot be converted into the form of P by Q. That's why these are not rationals. You may get doubt. as we converted non-terminating repeating decimal into the form of P by Q with the help of 10 or 100 etc., let us try to convert non-terminating non-repeating decimal also into the form of P by Q. You may get out. You see 0.563210510598 so on. It is non-terminating non-repeating decimal. Let it be x. As we took in the previous example, let it be x, let it be equation number 1 also. But our second step is multiplied by 10, 100, 1000, 10,000 on both sides according to its periodicity. In the previous example, 0.3 bar means its periodicity is 1. That's why multiplied both sides by 10 only. If its periodicity is 2, we have to multiply both sides with 100. If its periodicity is 3, we have to multiply both sides by 1000. But here we don't know what is the number to be multiplied on both sides because we don't know its periodicity. Why we don't know its periodicity? It is not periodic. It has no period. That's why we are unable to find its periodicity because it is non-repeating decimal. Period is exist for the decimal which is only repeating every time. But here it is a non-repeating decimal. Its period does not exist. Its periodicity does not exist. We don't know what is the number to be multiplied on both sides. That's why it cannot be converted into the form of P by Q. So that's why non-repeating decimal is not a rational number. So far, natural numbers, whole numbers, integers, decimals in that terminating decimal, non-terminating, repeating decimals are rational numbers. Observe that 0.5 is a decimal. Which type of decimal it is? Because of it is terminated at 5, it is called terminating decimal. So terminating decimal is a rational. It is a rational number. 0.6 is also terminating decimal. It is also a rational number. Observe that. Is there any other rational number exist between these two? After 0.5, before 0.6, we can see one more number like 0.51. It is a number. It is a decimal which lies between these two. But check whether it is a rational number or not. To check a rational number, we have sources: natural, whole, integers, decimals in that terminating, non-terminating, repeating. It is which category? It is a terminating decimal. No need to convert into the form of P by Q. According to that statement, we can say that it is also a rational number which lies between 0.5 and 0.6 only. Is there exist any other decimal except this in between these two? Let's see. 0.52 also a decimal lies between 0.5 and 0.6. Check whether it is a rational or not. Yes, it is also a rational because it is also a terminating decimal. So we have seen two types of decimals in between these two. Is there exist any other except these two? Yes, many decimals exist like 0.512, 0.5245, 0.5319, etc. So we can conclude a statement that in between any two rational numbers there exist infinitely many rational numbers. So this is the difference between previous sets and rational number set. In the previous sets, in natural numbers, whole numbers, integers, in between any two numbers there are finite number of those numbers exist, but in between any two rational numbers there are infinitely many rational numbers. That is the main difference we have to observe. Every terminating decimal is a rational. We have seen already. every non-terminating repeating decimal is also a rational. We have seen with example. In between any two rational numbers, there are infinitely many rational numbers. Also we discussed. And so far, we have seen that every natural number is a whole number. Whole number is a set containing natural numbers along with zero. That's why each and every natural number lies in set of whole numbers, and every whole number is an integer. Every integer is a rational number. Their converses need not be true. That is, every whole number may or may not be a natural number. Every integer may or may not be a whole number. Every rational number may or may not be an integer. And also observe that 3 by 5 is a rational number. Minus 4 by 9 also a rational number. Minus 3 by minus 7 is also a rational number. 0 by 5 also a rational number. In the first rational number, both numerator and denominator are positive. This rational number is a positive rational number. In the second rational number, numerator is negative, denominator is positive, resulting it is negative rational number. In the third, both numerator and denominator are positive. We can cancel also. So resulting it is positive. In the fourth rational number, numerator is 0, denominator is 5, resulting is 0. Whether it is positive or negative we see. What about 0 sign? It is neither positive nor negative. So there are how many types of rational numbers? 3 types of rational numbers. One is 0, second one is positive, third one is negative. And also observe that when the rational number becomes positive and when the rational number becomes negative. Rational number is positive only when both numerator, denominator are positive, both numerator, denominator are negatives. In other words, a rational number is positive only when numerator and denominator have same sign. Positive when numerator and denominator are positive. Negative when a rational number is negative, even it is 5 by minus 7, also negative rational number. Minus 4 by 9 is negative, 5 by minus 7 also negative. A rational number is negative only when numerator and denominator both have opposite signs. So these are types of rational numbers. Set of irrational is denoted by Q complement. Is a set containing the numbers which are not rationals. So far, what are the numbers not rationals? Natural numbers are rationals, whole numbers are rationals, integers are rationals. In decimals also, terminating decimals are rationals, non-terminating repeating decimals are rationals. Only non-terminating, non-repeating decimals are not rationals. A number which is not rational is called an irrational number. Non-terminating, non-repeating decimals are called irrational numbers, like 0.5317, so on, 2.673210, so on, like root 2, root 3, root of 15, square root of any number which is not a perfect square is also an irrational. cube root of any number which is not perfect cube is also called an irrational. Fourth root of any number which cannot be expressed as a power of 4 is also an irrational number. So these are irrational numbers, and also observe that 3.123 so on is an irrational number, 3.1245 so on also an irrational number. These are two irrational numbers because these are non-terminating, non-repeating decimals. Even in between these two also there exists an irrational number like 3.123125 so on. Even in between these two there exists one more number, that 3.1234, which is a rational number, which is an irrational number. So we can conclude a statement that in between any two irrational numbers there exist infinitely many rational numbers and irrational numbers. Set of real numbers denoted by capital R. So capital R is nothing but set of rationals union set of irrationals. Set of rationals union. Union means it is the combination of these both types of numbers, rational numbers as well as irrational numbers. The combination of rational and irrational numbers is called set of real numbers. A number which is either rational or irrational. A number which is either rational or irrational is called a real number. Here union stands for the word R. Every real number is either rational or irrational. Natural number is a rational number which is also a real number. Whole number is a rational number which is also a real number. Integer is a rational number, also a real number. Rational numbers, decimals, terminating decimals, non-terminating repeating decimals are also real numbers. And apart from that, along with this, irrational number is also a real number. So root 3 is an irrational number, it is also a real number. 5 by 3 is a rational number, it is also a real number. Root 3 by 2 is rational or irrational? Is in the form of P by Q. A number in the form of P by Q means, is it rational or not rational? Once again reminding you that every rational number in the form of P by Q, but a number in the form of P by Q may or may not be irrational. Even though it is in the form of P by Q, it is not satisfying other condition of rational number, that is P comma Q are not integers. That's why even though it is in the form of P by Q, it is not a rational number, it is an irrational number. Irrational number is always called a real number. This is also a real number. 0.57923 also a real number. 1.3721053 so on is also a real number, because it is an irrational number, it is a rational number. 2020 is a real number because it is a natural number, it is whole number, it is an integer, it is a rational number. 2020 is also a real number. Next, another type of set, that is set of complex numbers. It may not be in your syllabus, but anyhow we are discussing about types of numbers. That's why let's discuss about complex numbers also. Set of complex numbers is denoted by C. C is equal to set of numbers which are in the form of P plus IQ such that P comma Q are real numbers where I square is equal to minus 1 or I is equal to square root of minus 1. So you take any two real numbers, arrange them in this form, automatically a complex number will be formed like 3 plus 2i, or it can also be written as 3 plus I2. 3 plus 2i takes the form P plus IQ, and P comma Q, 3 comma 2 are real numbers where I is under root minus 1. 5 plus 0i also looking like P plus IQ. P comma Q, 5 comma 0 both are real numbers. I anyhow under root minus 1, it is also a complex number, but its simplified value is 5, which is a natural number, which is whole number, integer, rational number also. Means some of the complex numbers are real numbers. Like 3 plus 3 minus 0i, which is equals to 3. It is a complex number, also a real number. 7 plus I0 equal to 7. 1 by 3 plus I0 equal to 1 by 3. So all these are real numbers. See, you take any real number. 0.5 can also be written as 0.5 plus I0. It is in the form of P plus IQ, where P comma Q 0.5 is a real number or not? Yes, it is a real number. Instead of Q we have here 0. 0 is also a real number, so that 0.5 is a real number as well as complex number. Root 2 can also be expressed as root 2 plus I0. It takes the form P plus IQ. Instead of P we have here root 2. Root 2 is a real number, we know very well. Instead of Q we have 0, also a real number. That's why root 2 basically a real number. Now it is also a complex number. Not only this, you take any real number that can be expressed as P plus IQ form by writing in place of Q is 0. That's why every real number is a complex number. But converse need not be true. Every complex number may or may not be real numbers. Our today's discussion can be remembered through this. So it is easily identified by seeing this. Natural numbers. Every natural number is a whole number. Every whole number is an integer. Every integer is a rational number. Irrationals, rational numbers, together real numbers. Every real number is a complex number. And through this notation also we can remember easily. Natural numbers, all the natural numbers are present in whole numbers. All whole numbers present in integers. All the integers present in rational numbers. All the rational numbers present in real numbers. All the real numbers present in the set of complex numbers. Along with this, all irrational numbers present in real numbers. All real numbers present in complex numbers. So, in the number system, these are some types of numbers. In our next video, let's discuss about remaining types of numbers. Those are even numbers, odd numbers, prime numbers, composite numbers, co-prime numbers, twin prime numbers, etc. Okay friends, ఇది నెంబర్ సిస్టంలో పార్ట్ 1. పార్ట్ 2 క్లాస్ కోసము చూస్తూనే ఉండండి రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్ యాప్.
తెలంగాణ ప్రభుత్వం విడుదల చేసిన 2022 టెట్ ఫలితాలలో రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్ ప్రభంజనం. టెట్ పేపర్ 1లో 133 మార్కులతో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన జె అంజని. టెట్ పేపర్ 2 మ్యాథ్స్ సైన్స్ విభాగంలో 129 మార్కులు 127 మార్కులతో స్టేట్ టాప్ ర్యాంకులు సాధించిన జె అంజని ఎన్ సరిత. టెట్ పేపర్ 2 సోషల్ స్టడీస్ విభాగంలో 122 మార్కులతో స్టేట్ టాప్ ర్యాంక్ సాధించిన ఏ మమత. మరియు అన్ని పేపర్లలో 90% ఉత్తీర్ణత సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. 2017-18 DSC SGTలో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన మహేష్. స్టేట్ టాప్ 10 ర్యాంకులతో పాటు అత్యధిక ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. మరియు గురుకుల టీచర్స్లో TGT మ్యాథ్స్ స్టేట్ ఫస్ట్ ర్యాంక్ స్రవంతి, TGT బయో సైన్స్ స్టేట్ ఫస్ట్ ర్యాంక్ సుధా, TGT సోషల్ స్టేట్ ఫస్ట్ ర్యాంక్ బి శ్రీధర్, TGT సోషల్ స్టేట్ సెకండ్ ర్యాంక్ రాజేందర్ రెడ్డి, TGT తెలుగు స్టేట్ ఫస్ట్ ర్యాంక్ అంజన్ కుమార్, ఫిజికల్ డైరెక్టర్ స్టేట్ ఫస్ట్ ర్యాంక్ రాజ్యలక్ష్మి, ఫిజికల్ డైరెక్టర్ స్టేట్ సెకండ్ ర్యాంక్ దివ్య, TGT ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ శ్రీలక్ష్మి, PGT ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ మురళి, PGT ఇంగ్లీష్ స్టేట్ థర్డ్ ర్యాంక్ యాదగిరి. 2017-18 DSC గురుకుల టీచర్స్లలో 70 నుండి 80% ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్.
టెట్ మరియు DSC కోచింగ్ కొరకు
డైరెక్టర్ సిరికొండ లక్ష్మీనారాయణ గారి సారథ్యంలో అత్యుత్తమమైన అధ్యాపక బృందంచే కొత్త బ్యాచ్లు ప్రారంభమైనవి. వివరాలకు సంప్రదించండి 9246208422, 8885555202, 88585900, 8008954440, 8008954448, 8520844463.